All right, let's start things off. Welcome to Verkle Implementers Call 17. This is issue 1024 in the PM repo. Thanks everybody for joining. Starting things off as usual with any client team updates. Would anyone like to start things off?
Yeah, I can start. So, some weeks ago, Custodian 6 was launched. So some hours after it was launched, I was deploying some contracts and mostly to check this Witness Explorer thing that I showed in the previous call was working correctly. And for a particular transaction, I saw something really, really weird. At first, I thought it was related to the Windows Explorer because it was pretty new. But then I realized that was a get bug that we have. So I fixed that and we relaunched the testnet. The testnet, and I think since then things are working correctly. After it was relaunched, I redeployed all these contracts and tested that the fix was working, and it seems to be the case. Then Guillaume was syncing a new get node until to have like a more recent state, so we can do replay benchmarks and see again like performance bottlenecks, maybe get some insights regarding witness sizes and things like that, because our previous replay state was pretty old. So we will probably work on that soon. I think we still have to rebase some branches, things like that, but we are going in a good direction. And also we had some time to talk with many people involved in the EOF implementation to share ideas regarding how a world where Verkle trees and EOF would exist and how they will work together. And later in this call, I will do some small presentation to share those ideas and to maybe get more feedback from people. That's it from me.
Any other?
Okay, I can go from Ethereum just side. So we basically tried to stateless saying the Constraint 6 network after it was relaunched. And so basically we were able to sync most of the blocks, but in few of the blocks we found some issue like 6,128, 4,775, 4,487, and so basically block hash access was missing on this, and I confirmed that. So our block hash ring buffer was of the correct length of 8192, and then in 8915 block ext code hash was missing data. Basically we do a is empty block check over there, and which basically also looks into the balance nuance, and I think that data is not bundled as of now, and this is something that we have talked about previously and maybe could be decided and addressed in future testnet how it could be handled. And in block 6989, basically for self-destruct to beneficiary address, ETH.js is doing the beneficiary balance access, which was not present in the witness, and this was also basically discussed with GM, and will be decided how to handle it in the future. So these are sort of updates from Ethereum.js. Gabriel, anything you want to add?
No, not much to add here, except that we've fully migrated to the Verkle cryptography WASM. We used to use Rust Verkle WASM, but we've migrated to our own repo that we maintain that uses Kevandre's library as underlyings. So this paves the way for an actual Verkle try implementation, which will be able to provide a stateful sync as well. So I'll probably begin working on that as well. So yeah, that's it for my addition.
I think I can go next. Regarding the Gaussian testnet, so Nethermind failed on block around like 30,000. I think I know what the issue is. I'll debug it probably this week. Except for that, we are working on transition. So I ran some tests locally and some unit tests, and everything seems to be working fine. Next, we'll be testing the transition on kurtosis because, as far as I remember, Saritosh mentioned that you can now test transition on kurtosis. So that's the next step. And once I fix the bug for the Gaussian and testnet, then I'll resume testing the vocal sync as well.
Awesome. Anyone else?
I can go for Linus. So Advaita and Agnish are not present. I will represent them. So they made progress with integrating or implementing Verkle in our execution layer clients. So we have a problem in our client that there's some technical debt there around the database area. So that's what's been sort of slowing us down during the last few months. So we decided to split the effort into two, basically. And the first is to kind of circumvent the current database and just come up with something very basic for constant integration. It won't be used in mainnet. It will only be used in constant, but at least we can proceed with the integration. And going forward, we're thinking of a brand new, more than thinking, started implementing a brand new database that will support both Verkle and Merkle ground up, with a nice feature that it will be very storage efficient. So that's an ongoing effort. It will take a while, but after that, hopefully, we'll be able to really support Verkle thoroughly. So next step for us is continuing with the basic effort to integrate with consonant, and then we'll also change the gas costs. We've also been looking at the ET2 layer, at the consensus layer, to integrate as well into consonant. And there we encountered some other issue that, apparently Verkle is currently based on the Capella fork, which is a bit problematic for us. It's a bit buggy. So I'm asking that on behalf of Advaita and Agnish, whether there's any plans to switch to the Deneb fork in the consensus layer.
Not immediately.
Okay, because that would have made our lives easier, and we could have integrated it quicker on top of the NAB.
Yeah, that's understood, but unfortunately, Geth is going to have a hard time rebasing. I mean, by the way, this is something that I would like to add to the Go update. We have started merging some PRs into master, but everybody is aware of how long it takes to get stuff merged into Geth. So until this happens, we would have to go through yet another, if not two, really difficult rebases, and time is better spent somewhere else. So I understand the discomfort, but and we would like to fix that, but it's going to take at least a couple of months.
Okay. All right. Well, that's it on our part.
Cool. Any other updates?
I can. I don't know if you already shared something, Joshua.
No, I have not. Thank you.
Okay. So just on Bezu side, we started to join the testnet, the devnet. So we have a gas cost issue in the block 645 in a specific transaction. So I asked if someone can share me the trace of the transaction to understand what is the difference, because I tried to look at the modification in the spec and I don't see any problem, so I think I'm missing something. So yeah, if someone can share a trace, it will help me. We have also Thomas that is working on some optimization in Bezu. We have more people joining the team. So we have Gary that will help me to work on gas cost, and he will also start to look at the proof implementation with Thomas. So yeah, for the moment, mainly trying to join the testnet. Yes, Guillaume.
The trace you need, like, did I understand correctly that you just need a gas cost? Because if you do, you can use Ignacio's block explorer.
No, yes, the gas cost of each opcode, because I look at the Explorer of Ignacio and I don't see any difference. So I think I'm missing something else.
Okay, weird. Yeah, okay. I can try to generate you this trace, but yeah, I need to go home first, and it's gonna be like Wednesday.
Okay, no problem. Yeah. I will continue to look. Maybe I will find something before, but yeah, thanks.
I should also say that that block number that you are referring to is exactly the block number where I deployed and executed this more complex contract. So it is probably something a bit more weird.
Yeah, it
I
seems to
think,
be well.
yes, I was just saying that I think I can generate the trace and send it on the channel by tomorrow, probably.
Okay, thanks.
Cool. If no other updates, we can move on. I don't think there's anyone from the testing team here this week. I shared their update, their abbreviated update in the chat. If anyone has anything else they'd like to add as far as the testing side of things go, otherwise we can. Yeah.
Spencer wrote me. I don't know how different it is from the update you shared.
Yeah.
Let me just quickly have a look. Yeah, basically they want to. Yeah, they started using the new input that we gave them. It seems to work, but they've been delayed. They will start. They're trying to get something ready by the interrupt. That's what he wrote me.
Perfect. Cool. Okay. Well, then I guess next up is the Calcinin updates, V6 status and the V7 wish list.
Yeah, I think, but I've been disconnected from things that V6 doesn't really have any problems. So okay, Gajinder reported some issues that we can discuss if need be. Otherwise, we can discuss them offline. For the 7, my wish list would be to implement well, okay. First, confirm that there are some issues on the DevNet 6 and also fix them. But I know Aave and Uniswap were talking about running their scripts to deploy on the testnet. So I would like to do that on DevNet 6 if we could. Because I think it would be quite useful to find some like more bugs and try to keep DevNet 7 as the most stable testnet we've had since number 3, I think. And yeah, another thing that I would like to have on the DevNet 7 would be try to implement the fill cost, which so far was not implemented. I think it's time to tackle this before the interrupt, so that we can have some proper estimate of what the gas costs really look like.
Cool. Okay, if nothing else on that topic. Next up, a presentation from the Portal Network team, Milos.
Hi, can you hear me?
Yes.
Okay, I'm sharing the screen. Can you see the slides?
Yep, perfect. We can.
Okay, cool. So I already shared the link. Maybe somebody can also add it to the chat. I shared it on a Discord channel as well. Basically, I'm doing a research on how the Verkle state can be stored in a Portal network, meaning the archive state, entire archive state. I will give a bit of a background on what Portal Network is for the one that are not familiar. Basically, the Portal Network is a decentralized API for accessing the archive node kind of API for the Ethereum state. It's actually three networks in it, or subnetworks: Beacon, History, and State. And part of this research is focused on the State network. Currently, what is being in development is the state Verkle current state of the Ethereum network. And how it works is that every node in the network has a node ID, and every content has a content ID, and basically every node stores the content that is close to its own ID. That way you know where to look in the network specific content, like you know which other nodes is very likely to have it. And for the Verkle tree and the current Ethereum state, there are three types of content: the account tree node, which is basically the tree node of the main tree; contract storage tree node, which is the tree node that belongs to contract storage; and the contract bytecode. So very simple structure, nothing too complicated there. I'm going to skip the slides for the Verkle tree because I assume everybody here is familiar with that. So the naive approach for the Verkle case would be to basically do the same, store every tree node. But that has a problem. The problem is also present with the Verkle tree, but is less noticeable or less impactful. And the problem is that if you have a node, the tree node that is updating only one element from one block to another, the content ID will be completely different. So you will store it on some completely different space in the network. But you are duplicating how much storage the whole Portal network actually needs. And if the branching factor is 256, as the case of the Verkle tree, you basically have a lot of waste in memory that way. For the Verkle tree, the branching factor is 16, so that's still present, but not as noticeable, let's say. And that's one of the main problems. And the solution that I came up with was to split each node basically into two-layer mini kind of tree. So every node, instead of having 256 children, there will be two-layer nodes where basically they will accumulate the witness thanks to the Peterson hash, and where basically on the lower level, each node will just be a 16 consecutive values. And the one level above will just combine and add them. We can see that the others are basically just Peterson hash with 16 elements and everything else being set to 0. And the last commitment is just the sum of them. So there is no Peterson hash involved. There needs to be a bit of, let's say, careful engineering here, because the commitments that are being passed through on the lower levels are actually the elliptic points, not the scalar field values. But it should work. It should be possible to do it that way. This process can again be split into 3 or 4 layer trees with 4 elements, but that also increases the lookup value on the Portal network, because you would have more layers to go through to find the value that you're looking for. But it's something that might be explored of how long that would take versus how much saving in memory would actually bring, etc. Another approach that was being considered, which is more similar how the execution layer clients store the state, and that is that the same node on the same path would be stored within the same portal network node or client. And so basically the same node will be responsible for the whole versions of the same tree node. That one breaks one of the main assumptions, and that is that the hotspots, that it creates hotspots. Basically, some nodes would have way more activity for particularly popular like states that are updated very frequently. And basically that breaks like a symmetry and linear growth between the radius that portal network node wants to store and the storage size it actually will need. There was also an idea that we basically discussed even for the Verkle case, is to together look at the epoch, where not the epoch not in a sense of Ethereum layer network, but portal network kind of epoch, where the epoch would be longer period, and just the nodes would store the tree nodes within that epoch and the local changes. So basically something in the middle. This has a problem because every time there is a change from one epoch to another, you have to duplicate the entire tree state across the network, which is very bad. This is probably some approach that we might consider more when we go into storing only the header of the state, which will be probably stored in a different way and optimized for that specific use case. And this is probably the path that we will go for that. But for storing the archive state, this is probably not good enough. And that's a relatively short presentation from my side on what we are doing and how we plan to go forward. Basically, I just wanted to give an update and maybe ask if there is anything that anybody sees, let's say, wrong with this approach, or any suggestions or anything like that.
Looks great. Guillaume.
Yeah, I have a couple of questions. So, the whole structure was basically made so that it would make things easier for the portal network. So precisely because you requested this, like this is why we end with this tree structure. So I'm just a bit confused why you need to come up with this two-layered tree structure. And also, isn't that going to be extremely expensive to compute proofs?
Well, it depends. Like the thing is, like, I'm not sure what we will need proofs for. That's the first thing. The second thing is, if you have a tree node, and most likely from one block to another, only one value will change in that tree node, except the root and maybe the first layer or first two layers. So then you will have to duplicate the entire 256 values and store it somewhere else in the network. And that's a very high duplication factor of how much total storage the whole portal network would need to keep the entire archive state. So I guess that's why that's the benefits of, that's the idea of splitting it into multiple layers. And what was the other question?
Yeah, just why? I mean, the proof, right? You answered the proof. I mean, my question was like, are you no longer interested in the structure you lobbied for us? Okay, maybe lobbied is a big word, but you asked us to adopt, basically.
Can you clarify which one?
Right. So this whole single tree structure with 256 values and everything merged into a single tree. That was a request by Piper, right? The reason why we have this, we no longer use the per account. I mean, there are okay. Now we found that we could adopt this structure for our own purpose and make a lot of optimizations based on it. But until Piper made this request, the whole point was that the structure of the tree used to be an account tree and storage trees below them. So we changed the whole structure to adapt it to the portal network. I mean, I'm just wondering, are you suggesting we change the whole structure of the tree ourselves, or is it just an internal portal network representation? That wasn't clear to me. This 16.
Right. No, this would be just the portal network internal representation. So how the structure would be stored within the portal network. And this approach, I can probably go back there. With this approach, this would basically represent one node of the Verkle tree, how it would be represented within the portal network. And the end-up commitment would be the same as it currently is, because it's just linear algebra combined together. So there will be no change, or this doesn't require any change of the Verkle tree structure. This will just basically be how it will be stored within the portal network. I now understand what you mean between like embedding the smart contract storage within the same tree. I actually wasn't there. I wasn't part of the portal network at that point, so I'm not really sure all the reasons. I mean, it definitely helps us from having more unified storage across different areas and stuff, so it's still useful. This proposed change doesn't actually affect anything regarding the Verkle tree design of the, like, for the execution clients or anything like that. This is just how we would actually store it within the portal network. And regarding the proof, it would basically be that we in portal network would most likely not use this kind of proofs. We have a system where currently with Verkle tree, whenever the data is gossiped within the portal network, the data that is gossiped has to be proven that is valid. And the way it currently works with the Verkle tree, you pick one leaf that you want to store that was updated, and then you gossip that basically that leaf and all of its parents at once. And how it works is that the node responsible for that leaf would receive the leaf, verify the proof, and then it will just remove the leaf and gossip the parent of that leaf to the rest of the network. And that would sort of like recursively propagate all the way to the root. So basically, when we gossip, we don't actually, we actually want to have all of the parents already provided there so that we can recursively gossip them. And for the Verkle tree, I guess we would probably preserve the same logic, which means we don't actually benefit much from the ZK proofs that we can actually get from the Verkle trees. We didn't do much of the work in that area of whether we can optimize something there, but that's the initial thinking. We would still just propagate the leaves and all of the parents with the full content, such that we also have to, because we also have to propagate them through the network as well anyway. So that's kind of like the thinking that we might actually not, but I agree, this kind of proving scheme would probably not work if you want to concise proof for the, in a later stage. And you would still have to iterate through the tree to find the node that you're looking for.
Right. Okay. Thanks for clarifying. Another question I had, but you already kind of touched to it just now. Like the top of the tree, like your problem is the churn at the top of the tree, but we already have this kind of information attached to the block, right? So if you see your information inside the block, that means it has been touched. But if you don't see it there, it's you need to find where it was last touched in the block. So yeah, you could like, if you want to write an archive node, or okay, not a node, an archive network, you would be able to get those nodes directly from the proof. So you could get it by doing some archive of those proofs themselves instead of reinventing your own method. I mean, it's just food for thought for you. You know best what you need, but maybe there's some potential saving for you either in design or storage by looking at what's in the blocks already.
Yeah, I briefly was thinking about that. The problem is that the portal network is designed such that the nodes in the network can join and leave kind of randomly, and they were not going to go and fetch all historical blocks and keep updating themselves. So there has to be a mechanism where you can just join, and then the content that is that is close to your node ID should be given to you or seeded to you through some means, and you can keep following what is happening currently with the head of the network. But if you disconnect, like there is no strong requirements or expectations that every node will observe every block header all the time and have everything updated. And that's why I didn't actually find a way to actually fully use that information in this kind of distributed structure. But definitely something that I was looking into and still thinking about, like, because we will have we call them bridges that will actually going to seed the data into the network, and they are probably going to use this information very heavily. But from individual nodes point of view, it's a bit harder because they don't have the same expectations, let's say, from them.
Right. Yeah. One last question in this regard. The churn that you expect, what is the depth that you expect it to be a problem? Is it like depth 1, depth 5, well, 5 is going to be hard to reach, but for a Verkle tree. But do you have any idea of where the churn starts being a big problem?
I mean, nothing seems to be a big problem per se, because, like, I'm not sure what you mean by a problem, because we will just store it the way we kind of designed the storage layer to work. The problem is, the idea is that if you want to find a balance on some archive state like million blocks away in the past, you would know the state root and you would have to traverse the tree, and you would do that by issuing the queries through the portal network for fetching each tree node on the way to find the leaf that you're actually interested in. And if we do this splitting, then the deeper the tree is, the more query you need to make on the portal network, meaning it will take a longer time to find information you're looking for. So that's a trade-off. Like, technically, we can go all the way to the binary tree, but then that would just take way too long. And on the other hand, if you have like a big branching factor, then you increase the demand from the whole portal network storage, like combined storage of the entire portal network. You increase the requirements of how much that should be to support everything. So there is like a trade-off on latency versus the total global storage. There is no like a strong requirement that it has to be smaller than this or bigger than this. It just like depends on like a preferences and trade-offs.
Okay. I'm not trying to redesign your entire thing right now. Well, you're putting you on the spot. One last question I would have, but you were also talking about potentially meeting in Prague. Would you, by any chance, be in Berlin before or after?
I'm not. I don't think anybody else from the team would be there. I know the entire. Okay. Almost entire portal network will be in Prague, but I'm not sure if anybody would be in Berlin.
Okay. Okay. Then let's see. But yeah, I think there's some iterations. Like we could try to iterate on that if you're interested. One question, last question I had, because I don't want to hog the entire call. Would it be possible for you guys? Like, do you really need to have every single block, or could you just have the history for every let's say every 1,000 blocks, and then ask people to resync the node based on the proof from the blockchain? Would that be a model that would be realistic for you guys?
I mean, we would have to think of the use cases of, like, it depends like how exactly would that be stored. I guess we currently weren't thinking in that direction. That's one of the ideas that something similar, let's say, is this idea of having epoch and path, let's say every 10,000 blocks or something. And then every node would store the state of a tree node at the beginning of that epoch and all the consecutive updates. The issue with that is that we encounter is that we would have to reduplicate at the beginning of every epoch. We would have to reduplicate the entire basically state. Basically, we would have too much snapshots that we will store across like the entire portal network. Like we will still have to do some calculations to figure out how much exact, because as you keep adjusting the epoch, like making it bigger, that problem becomes smaller. But then the problem of the hotspots and having some nodes having to do way more work than the others becomes more exaggerated. So there is also a trade-off in that design. So it depends on the use cases. What exactly would that be? It's something that we are kind of want to explore. But this approach of using the path for the content ID, not just like a commitment, is something that we are most likely going to pursue for storing the head of the block. That way you can achieve maybe off one request for the head state. And that's something that that's going to be a completely separate discussion and research on that area. It's a bit lower priority for us at the moment.
Cool. Awesome.
Thanks a lot.
Thank you, Milos. Cool. Okay, since we only have 22 minutes left, we can try to get through the rest of this quickly. Next up on the agenda, there's a topic around the 32-byte chunking ideas for Verkle. I think Ignacio, maybe? Was this you on the agenda? Or Guillaume?
I think it was me.
Okay, yeah, sorry.
Interrupt me, Ignacio, if you had any. If you thought that was you. Yeah, basically not much to say. What I except that in order, because of all this EOF Verkle considerations we had, it's something that had been talked about with Pavel a long time ago. I wanted to finally take some time to try to implement it, to see if we could get more information as to the benefits of packing everything, like both to evaluate the impact that UF would have, and also to see if it wouldn't be an optimization that is interesting for legacy code, legacy bytecode as well. So I want to do this. The question I had for the community would be, do we want to put so in this model, what we would do would be to put the byte, instead of putting the byte at the beginning of each chunk, like the push data byte at the beginning of each chunk, we would put that in a buffer somewhere. And the question is, where should this be? Either we put it at the beginning of a 128 block. The first 128 leaves. The problem is we have to somehow store the actual start offset, or I guess we could compute it from the size. That would be possible. But then we probably, that has a gas cost impact, because we would need to access the size every time we need to touch the code, which is not currently the case. Sorry, actually it is in the current EIP, but would not necessarily be the case in the future version of this EIP. Or we could put it in the reserved. Well, some of it, because that's the problem. We could put some of it in the reserved leaves of the header group, but in case, even if the code is currently 24 kilobytes, that would not fit in the available space. So we would need to find a way to overflow, or we add yet another offset. And then that means that every time we read the code, we have to go get it somewhere else. So that's an extra cost. I'm not sure which one is the best approach. They all have their drawbacks. I wanted to know if anybody had any opinion as to where this section, let's call it section, would have to go.
I mean, I agree that it's very hard to predict. Probably we will need to test the two ideas of like putting this information in the header and not putting there, because it kind of depends on the contract, I guess, and the length of the contract, right? Because the amount of bytes that you need depends on how many chunks the contract has. So yeah, it sounds like it will depend on each contract, really.
Yeah.
And also,
So
like
when
another thing is that if we pack together each metabyte byte, my feeling is that whenever you read one of them, you will be indirectly like loading the metabyte of chunks next to each other, and I don't think that's entirely useful, because this metabyte byte is only needed whenever you do a jump to really check that this jump is correct or valid. And the chance that whenever you execute a chunk, you will jump to a chunk that is really next to that chunk, I don't know how probable that is, and how much you will leverage these other metadata bytes that you have read already. I know if that makes sense. It was a bit of a tongue twister, but
yeah. No, it's totally understandable. Yeah, that's the biggest problem, and in fact, that's the problem with the whole section reading in EOF. I mean, this is what I'm sure we will discuss that in just a few minutes. But I think it's still worth being tried so that we have concrete data. So I don't know where to start, but I'm afraid the answer is we have to start all two or all three, depending on how you look at it. I'm just not sure where to start, really. I think, I think I will first try to do it, put some of it in the header, and then somehow use the same technique for the overflow. Yes, it's definitely going to be extremely expensive to, if you have to read an extra section just to every time you read a new chunk. Sorry, a new chunk every time you read another chunk. And in fact, this is exactly what Vitalik said in the EFV0 PR. But yeah, okay. Let's say unless there's anybody else disagreeing, I will start with that. I will put it in the account header, and at least it will serve as a base point, and we can try to optimize afterwards.
Cool. Okay, last up on the agenda, a presentation on Verkle and EOF from Ignacio.
Yes, I will share my screen. Can you see my screen?
Yep, perfect.
Okay, yeah. So these last days we have been chatting with some people from EOF, trying to exchange a bit of our thoughts regarding how a world where Verkle and EOF will live together will look like, and which are like some concerns and things like that. So the idea of this presentation is mainly like sharing all these ideas for others to be aware. So a bit of context that probably everybody knows already, but EOF is being considered for Prague, and Verkle is being considered for Osaka. Prague comes before Osaka. So the idea is to try to see how these both EIP interact with each other, and try to see the impact of them on Verkle users, on Ethereum users, on the Verkle tree spec and implementation, and also see if this might put some create maybe some problems for EOF adoption. So it's mostly like an exploration of all these topics. As to give like a really quick DLDR on Verkle trees, only like focused on the discussion of this presentation. The main motivation of Verkle trees is to make stateless clients viable. And for that to happen, Verkle trees needs to introduce this concept of an execution witness, which is basically all the data that you need for replaying a block in order to verify it. Because stateless client do not have any Ethereum state, so you need to provide them all the needed data to execute the block. The important part for this topic is that Verkle trees now include the smart contract code as part of the state in the state tree, which is something that it isn't true today. The smart contract code is usually like in the client's database, so it's not really in the tree. So with that point in mind, there are like two really obvious conclusions. The first one is that the bigger your contract is, the more gas you will have to pay, at least compared to the gas that you pay today, which is 200 per byte, because you had to write all this code into the tree, which is more expensive. So that's the first one. And the other like insight in quotes is that whenever you execute a transaction, the more bytecodes that your transaction execution needs, the more gas you will have to pay, because we have to include all this bytecode in the execution witness. This is a cost that is like new for users. Today, they don't have to pay for all this, of course. And this is like something that contract developers and compiler devs will have to think about, because it's like a new optimization dimension that they should account for. But the bottom line for Verkle tree's perspective is bigger contracts and needing more bytecodes will mean paying more gas. Okay, so that was like a TLDR for Verkle trees. If we do the same for EOF, which I'm not an expert on, so have that in mind. The idea of EOF is to add more structure to the smart contract code. So it introduced some new sections like the header and type sections. It also includes a lot of new instructions and ideas to make the code execution more efficient, and also allows the client to avoid doing some runtime checks, just like the jump test analysis, because like I think that every jump should be valid, so that's like a reasonable amount of work that clients shouldn't do at runtime. And all this structure allows also to make like the EVM like spec more evolve better, because you can add and remove features or instructions without breaking existing code. So all these benefits have also, or might also have some effects, such as like maybe bigger code, because we have to include like new sections, and also maybe having to read more bytecodes while executing transactions, since we might have to read totally or partially these new sections. Okay, this is like open questions. So if we merge together these two insights of EOF and Verkle regarding gas concerns, we could say that EOF might increase the code size and might need more bytecodes to be read during contract execution. And these two things are exactly the things that Verkle trees make more expensive, because we need to add the contract to the tree and also include the bytecodes in the witness. There are a lot of caveats here, because EOF, as I already said, bring new efficiencies. So for example, the sham test instruction can be avoided, so the contract size might be smaller from that angle, and that might offset these new headers that will be included. Also, there's like a lot of work that compilers can do to really optimize for the code layout, or how these EOF sections are placed in the tree, such that you have to read the fewer number of chunks possible. Now, how much all these efficiency gains or potential optimizations can offset the new costs is like the thing that we are trying to figure out. A potential idea to explore this a bit is to try to come up with a client that have both at least a minimal implementation of EOF and Verkle trees. launch a testnet with that client, or maybe just run a simulated chain locally and try to deploy a set of reasonable contracts, both compiled with legacy code and with EOF, and just like execute transactions on these contracts and compare the gas costs. So ideally, we would like to have compilers that are already accounting for both EOF and Verkle trees optimizations, because even if you have compilers optimizations only for Verkle trees, there will be missing like considerations that would make sense for EOF. And if you have only EOF compilers that have optimizations only for EOF, that will be missing all the code chunking optimizations. So asking for this is very hard because this is a lot of work and compiler teams have really probably limited bandwidth. But yeah, at least even if we don't have these optimized compilers, at least with this kind of test, we can have like an upper bound of the gas difference. And if we try to do this kind of testing, maybe we can have some feedback loop to improve the EOF and Verkle specs so they can place better with each other. There's another angle apart from gas cost risk, which might be EOF adoption risks, which this entirely depends of if EOF versus legacy has a big gas difference. So kind of depends. But if there's a gas difference that is reasonable, maybe users will simply try whenever they deploy a new contract to deploy it with legacy code and with EOF and simply do the deployment with whatever setup it uses less gas for them. And that might be a bit annoying because that this might make harder to stop accepting legacy code in the future, which I guess is like the idea, because if that isn't the case, we will have to accept that we will have two modes of contract execution forever. And I think that will be, I mean, not entirely nice for complexity reasons for clients, I guess. Not only for full clients, but also for stateless clients, which should also be aware of these like two modes of contract execution. Regarding Verkle tree complexity risks, one open question, which is a bit related to what Guillaume was talking about before, is we have to figure out how code chunking will work for EOF, which will probably be different than for legacy code. So there's like a chance that we will have like a, let's say, double spec for legacy and EOF executions in the Verkle tree spec, because depending on the contract type, we have to explain how chunking works differently and things like that. Also, EOF introduces a bunch of new instructions, and depending on these instructions, we will have to figure out probably new gas costs for them, if there are any that indirectly risk the tree state. So for example, today, instructions like balance and block hash indirectly require state from the chain. So these instructions also require some extra gas cost considerations because they increase the witness size. And finally, due to the complexity of EOF, there's like a reasonable chance that this can delay Osaka fork. And while this happens, the state growth is still, of course, happening. And maybe the state transition between the Merkle Patricia tree and the Verkle tree will take a bit longer. And yeah, we will prefer this to take the short amount of time as possible, because there's a lot of logic happening and there's like a risk here. So I think that it's fair to say that it might seem that EOF and Verkle tree implementations are non-overlapping because they are seemingly touching different parts of clients. But the point here is that their effects are really composing with each other, mostly like the gas cost effects. I think that the original EOF assumption was that doing all this code structure changing wouldn't affect much gas costs because the code wasn't really part of the tree. But since Verkle trees need to include code in the tree for stateless clients, then we have this situation in which these seemingly different EIPs interact with each other at the gas layer. Like an open question is maybe a more minimal version of EOF can help here. I mean, I don't know. Kind of depends what a minimal version of EOF even means, and if it really like helps with any of this problem. Just to clarify again, this presentation isn't about saying that there is a problem or a big problem. The only thing that we are trying to share here is that maybe we don't know, and a lot of these questions might have a it depends answer, and it maybe would be helpful to really find out if any of these things are things that will backfire in the future, and yeah, trying to be have more like real data to support or simply discard these concerns. So that's it. And also like the idea is to share all this with other core devs and get their feedback and ideas about these things.
Any questions or feedback?
Well, I have a question. You mentioned that this is the first time and I got aware of the EOF, and you mentioned that the goal of EOF is to no longer keeping the code in the tree, in the Verkle tree. I mean, no longer kept in the storage. So how could the block builder a block builder to know which code or which transcript to execute or to verify? Because even if the block builder owns the whole storage, the entire storage, and there's no code included in the tree. So how did the block builder know which code will be triggered in a transaction to build a block?
So I'm not sure that question is related to this topic. Like block builders will have all the states of the chain. So if the contract is an EOF contract or a legacy contract, they will know anyway. And I'm not sure this is related to EOF or Verkle really.
Not for Verkle, just to make sure that if there's no code stored in the trees, installed in the storage. So also so in which form will the code be presented to the block builder as a key snag or something else?
Maybe just since we're at time, we can continue discussion async unless anyone wants to. I'm curious, I guess, to stay on the topic of EOF. If anyone else here, not to cut the conversation off, but I know Dano is here, and I don't want to put you on the spot, Dano.
Yeah.
But curious if you have any quick thoughts.
Yeah, are the slides available? Because there are some things I can clarify. I think the biggest thing to mention about EOF is that its core is just a container format. We don't change fundamentally how the EVM works. So one of the big concerns about how we're going to keep two versions of the EVM, it's going to be the same operation execution loop, and you're going to be asking the same questions. Like instead of asking, well, am I Shanghai, am I Byzantium? When you operate an opcode, you might have an extra check to say, is this frame EOF? And if so, execute. Otherwise, don't execute. So a lot of the core logic in there is going to be absolutely the same, and that was one of the goals of EOF. The big goal of EOF was to build this container format for the EVM so we can do things like add operations that use immediate arguments, which is impossible to do safely with the current legacy system. There's been high-level requests that then include other large goals of the EVM future into it, which include things like removing the ability to introspect code and removing the ability to introspect gas while you're running. which will open up a lot of things like the ability to willy-nilly change the gas schedule without fear of breaking contracts that are deployed. If you can't read the gas, then the solution is just to always provide more gas. So those were some of the things. That's why, it looks like there's a lot of opcodes, but what we're doing is we're just replacing opcodes that in a way that can handle this container format, and they operate exactly the same, just they might use immediates. They might not have gas introspection. They might need to use a data section to get at their embedded data. So that's where a lot of these things come from, is taking existing behavior patterns and containerizing it. There was a prototype Mega EOF compiler written by Solidity before Big EOF got pulled from Shanghai. And in some tests I've done there, I've seen between 1% to 3% opcode size reductions of bytes, but I don't know how that's going to translate to operational. There may be less bytes, but there may be more operated more effectively. So the biggest open question we won't really get answered until we start getting quality implementations from Solidity and from Viper against the current EOF spec. I'm hopeful it's going to be less, but it might be large, but it won't be, anything outside of the 1% to 3%. I'm expecting either way. It's, going to be statistical noise for a lot of these. So I'm not expecting any major large size or operational gas cost gains. Anything that is costed in the header tends to be offset elsewhere, but because of contract size restrictions, we really can't, multiply those gains within a contract. So it's going to be mostly a wash, is my expectation. I think those are a lot of the high level concerns out of there that what my expectations are going on right now with.
I know we're over time. Could we please share the last slide again, because there were a couple of questions that I'd like to go over. The fact that it doesn't change, the fact it doesn't change anything about the execution is demonstrably wrong. But okay,
How is it wrong? What are we fundamentally changing?
We just showed you that the gas cost was going to change, so it was going to be affected. So yes, it's demonstrably.
So that's
just demonstrated to be wrong.
That's details. But the fundamental model's the same. What I'm saying is the model's the same. The details might change, but the model's going to be the same. We're going to burn gas. We're going to have message frames. We're going to color the contracts.
Right. So the devil is in the details. But okay, let's save this one for the ACD. My question was like the one I'm interested in is I know you've been asked in the past to do EOF like a minimal version, and then someone swooped in at the last minute and asked for the big version of EOF. But I'm still, let's say the context has changed. That was before Cancun. Now Cancun is there and Verkle is next. What could we get as a minimal version of EOF? Like let's say EOF comes in three versions, like 3 forks or 2 forks. What could we get that would still be useful and at least be small enough a scope that we could study it and not go back and forth on the question forever?
So the first thing you do it in 3 forks, you're going to have to maintain 3 more growingly different versions of the VM. And if we have to break the contract format multiple times, then we'll have to support those multiple contract forms forever. One of the requests is if we're going to break these things, then we break it once. And there's only one difference between an EOF contract and a legacy contract. We don't have a legacy contract and then a container contract that has gas introspection, and then a container contract that does not have gas introspection, still has code introspection, and then one that has everything that we need. So if we have those 3 different container things, that's going to be a huge technical debt. So the first requirement that is a lot of credence is if you're going to break as much things at one time as possible. So we need to get banning code introspection and banning gas introspection and preparing for address space expansion in the first go. Otherwise, forever, we're going to be supporting 2 or 3 different contract formats. I mean, we're already supporting 2 different versions of the access list transaction because they shipped like just a few months apart. So we got access list and we got 1559. We're trying to avoid this by doing it in one big go. Otherwise, everyone everywhere is going to have to support all 3 versions forever. So to split it up into smaller parts actually increases the surface area. of what downstream consumers are going to have to support. It also increases the surface area for testing and the surface area for attacks. There might be some design issue in V2 that's not there in V3, and then we have to worry about all the details on that. So while it might make it easier to deploy and get out, to do it in 3 different steps, it significantly increases the risk and surface area of where things are going to need to change. So that's my concern with splitting it up. I mean, I think that was the initial pitch. But when you start looking at the security and maintenance issues, it creates more of a problem than it solves.
That's a fair enough assessment. Although I would counter that, yes, it's we want to break as little. Well, we want to break stuff as few times as possible. But if the breakage is orders of magnitude bigger than each individual breakage, I'd rather have several smaller breaks than one big break. But okay, so just to be clear, I understand your point, and it's completely fair. But just to have my question answered, the minimal version of EOF, what would that be?
Minimum version of EOF would be one the compilers would actually write compilers for. And I think that includes, we could probably get rid of the TX create and opcode, but I think everything else there, we've tried to pare it down. So we only put the minimal features in there. And if we cut much more out of it, compilers won't pay attention to it. And they're our primary customer. If compilers won't compile the EOF, it's a dead feature. Back in Berlin, we had subroutine opcode proposed to go in. And it got pulled very late because Solidity came in and said, hey, we won't use this. So the real litmus test on how much can we cut is how much can we cut before Solidity and Viper will say we're not going to use this.
Okay.
And I think we're there.
But what's there? Okay, so in your view, like at most we would still have to ship 18 instructions, and on top of that, okay, just something. I remember that story. That was not EOF at the time. That was EIP. I'm trying to remember 617, or maybe that's the anyway. Yeah.
615.
Why 615? Thank you. Why do they feel this? Do you know? Like, why do they feel that static jumps are not good enough for them?
What do you mean, static jumps? Dynamic jumps? Why are dynamic jumps such a problem?
Right. So yes, sorry, dynamic jumps.
It's impossible to analyze in static time. You can write code in there that has order n squared, order exponential complexity jumps in analysis to prove it's safe. Because if you jump from something on the stack, you can introduce data from outside of the code to determine where that's going to jump. And you can write these horrendous compiler bombs that will absolutely freeze up your block production.
Right. So sorry, that was actually not my question, but thanks for the refresher. That was useful nonetheless. My question was why do you know why Solidity, and I think that was Christian at the time, who said 615 is not going to make it because we're not going to do that. Why would they not do this?
So one of the issues had to do with immediate arguments. When I do my EOF presentations at conferences, I always start out with showing how if we were to add an immediate for static jumps today, how it would change the interpretation of other contracts that may already exist on the blockchain. And if this is known ahead of time, trolls will come in and create problems on the chain. We've seen this before in some other spaces we've tried to preserve, such as preserving the EOF 00 header. We wanted to have it just be EF, but someone came in and put in EOF emojis because they thought it would be funny. So people are going to come in and troll the chain. And then the Shanghai attacks were absolutely there just to slow down the chain. So we can't just add in static. You just can't add in immediates. We also can't add in code separation, code and data separation, because there's no effective way to show what the difference is between data and code. You could jump into code at the end. And there are a lot of contracts out there that interleave their code with their static stuff, and we can't just shut that down. So we need to figure out, it's some of the existing patterns that are in use that we can't just invalidate because they're already out there live on the chain.
Yeah. Okay. Yeah, that clarifies things. I will try to talk to Daniel because last time I talked to Daniel about this stuff, he seemed pretty psyched about it. So, yeah, I mean, okay, Daniel is not Christian. It's Daniel's problem. It's no longer Christian's problem. So, opinions might change. I guess I will. It's understood that the compiler, whether or not they want to go over the threshold and implement them, will require some like an effort that is like it's got to be worth the effort. I will talk to Daniel in Berlin when I'm back to Berlin and see what would be the cutoff for them, and then we can continue that. But okay, thank you. I understand the context now.
Thanks.
Thanks, Dana, for joining the call. You're always welcome to come back to future VIX if you'd like. Cool. And perhaps we can do another call if folks want to on this topic of EOF and Verkle. It'll definitely
Happy to do one.
Yeah, cool. It'll definitely get brought up on ACD as well. But yeah, thanks again, Dana, for coming and just helping to share your thoughts here. Cool. Okay. Well, yeah, sorry we went a bit over. Thanks everybody for joining, and see you again in a couple weeks.
Thanks.
Thanks.
Great.